These are Forstner bits. This is just one type of bit that you use when using the drill press. These are just standard twist bits. These are the ones you use most commonly on the drill press. Lots of those around, lots of different styles, lots of different sizes. This set runs from 1/16 up to 1/2 inch. These are spade bits. Spade bits you use for larger holes. Can't be ran at a fast speed because they aren't a balanced bit. It can cause the bit to bend if you're running at too fast a speed. But the spade bits are a really good set of bits and really good for larger holes. This is the drill press. Okay, every drill press, when you use them, you should always have a backup board. The backup board is there so as you're drilling through that you'll drill into the backup board and never into the tabletop surface. The chuck key, which hangs on the side of most of the drill presses in our shop, is used to put into the chuck. As you twist the chuck in a clockwise direction, it will loosen. You put your bit in. As you twist in a counterclockwise direction, it'll tighten onto the bit. Then you take your chuck key, twisting your chuck key in a clockwise direction, tightening the bit. If you tighten it more than one spot, each spot on the chuck will tighten to a different level. Make sure that the bit's in there tight. In this case, we're using a hole cutter. A hole cutter is used anytime that you make wheels, anything you need circular cutouts in your wood. It's very important that when you run a hole cutter that you always make sure you run at a slow speed. A hole cutter is an unbalanced bit, and if you run it at too fast of a speed, it can twist and actually throw itself out of the machine. The speed adjustments on most drill presses are done in a belt system in the top. On some, you'll actually have a lever on the front that you can adjust the speed. On those machines, you have to make sure the drill press is on to adjust the speed on those. In all of the drill presses in our shop, the speed will be preset. It'll be designed for the wood, so you should never have to worry about making adjustments. Okay, one of the things you need to be really careful of is when you're using a hole cutter that you clamp any type of wood that's shorter than 12 inches in length. In this case, if this piece of wood were to spin, it wouldn't catch that back post and it could spin around and damage you or the machine. So just for demonstration purposes only, we'll go ahead and allow the hole cutter to stick in the wood and show you what we mean. So if the machine's running and the piece catches, the wood will spin. Okay? If the wood does spin, just maintain feed pressure and stop the machine. Don't ever let go of the feed handle. If you let go of the feed handle, then the wood could get out from the drill bit and fly out in any of a number of directions and cause a very severe injury. In this case, we're going to go ahead and make a wheel with the hole cutter. Ideally, you'd never want to do this in the center of a piece of wood just because you're wasting material. You always want to try to do the wheels on the end and get as many out of a piece as possible. This is a piece we had from earlier demonstration, so we'll go ahead and use it. When you go through and you make a hole or make a wheel with the hole cutter, you always want to make sure that you stop short of your backup board. You never want to go all the way through from one direction because the wheel will end up wedged up inside of the hole cutter. So we'll go through and we'll cut a little more than halfway through the piece of wood. We'll stop, we'll back it out, we turn it over, and we'll have a pilot hole. You just line up that pilot hole with the inner drill bit, you drill down, and you'll feel the drill bit breaking through. When you feel it break loose, just ease up on the feed pressure, lift it back out, and your wheel pulls right out of the hole cutter. And it doesn't wedge inside, it's much easier to get out, and they'll come out cleaner that way. A little bit of sanding, and it's ready to be used for a car or a toy or for any other purpose. When drilling pieces that are shorter than 12 inches in length, you always need to make sure you clamp them to the tabletop. You can use a C-clamp, it's used here, or you can use a hand screw clamp to clamp either type will hold the wood down and make sure that it doesn't spin out while you're using it. Once it's clamped in place, you can start the drill bit and drill. And if you feel the drill bit breaking through on the bottom, always ease up on the feed pressure so you don't drive the pieces or drive the drill bit too deeply through the wood and into the tabletop. clean hole, no splitting, and that's because you've got a backup board that will keep the wood from splintering out. This is the belt disc sander combination. It's got a disc sander on the side, a belt sander on the front. This is the one that you use most prominently in the shop. We have two belt sanders that lay down, that have smaller discs on the side. We also have spindle sanders, but this one tends to be the biggest problem. When you're using a belt sander, you should always take a tri-square and check and make sure that the belt and the table are square. If the belt and table aren't square, everything you sand will end up not being square. You can do the same thing with the disc side. You can always check and make sure that the table and the disc are square. And when you sand using the disc side of the sander, you can only use from the center of the disc to the front edge. The disc spins in this direction, always forcing the wood down. If you sand on the back edge, then it's constantly going to try to lift the wood up as it sands and throw the sawdust up into your face. So anytime you use a disc sander, always use the front to the middle on this side of the direction it spins and not use the back edge. When you're using the belt sander, it's really important that you use the entire belt surface. As you sand, don't sand just in the middle or just on an edge. As you sand, work your way back and forth across so the whole belt surface wears out and doesn't wear out in any one spot. Occasionally when you sand, you'll see black spots or dark spots on your wood. Sometimes that means that the wood is really hard and the belt surface isn't good, or you're sanding too fast. The most common reason is because the belt surface has gotten worn out or it's got filled with sap and material, and instead of sanding through the material, it's actually burning its way through the material. Another thing you need to be very careful of is when you do corners. A lot of times kids will try to sand corners in a direction like this, where they try to support the wood and hold the wood up. The reason we never do that is because we heard of a student that was doing that, and he had a block that he's doing, and he's sanding and he's holding his wood like this. As the sander caught it, it pushed it down into the miter gauge track and pinched his fingers between the belt and the wood he is sanding, and it literally pulled 3 of his 4 fingernails off of his hand because he was sanding the wrong way. To make sure that you never have that happen, always sand your corners with the wood sitting flat on the tabletop, and then sand it in a direction like this. This way, the wood is always supported, there's no place for it to catch, and you'll never have any problems. Plus, you'll get much cleaner corners when you sand in a direction like that. This is a miter gauge. A miter gauge typically is you will find on a table saw, but the miter gauge can be used on most any of the machines in our shop that have a miter gauge slot. It can be used on the belt side, it can be used on the disc side, it can be used on band saws, and like I said, it will be used on the table saw a lot. If you use the miter gauge, you can guarantee that your wood will stay square if you use the miter gauge while you sand, because you can turn on the power, holding your wood flat, the miter gauge and the tabletop will always make sure that your wood stays square. If you have material that you want to come out nice and square, use the miter gauge and make sure your tabletop's square, and you know your pieces will always come out perfect. When you finish, always make sure that the machine comes to a complete stop before you ever leave. Okay, the spindle sander is used for any of the curves, round shapes that you need to sand. Spindle sander spins in a clockwise direction, so when you use the spindle sander, you need to make sure that you feed it to the direction of the curve. So that would mean feed it from the left to the right, into the direction of the spin. Keep your wood from getting kicked out of the spindle sander. This is the scroll saw. Scroll saw is used anytime you want to do curves or real intricate shapes, scroll work on wood or plastic. Using the scroll saw, these little metal devices are finger guides. Finger guides need to be touching your material. So when you adjust the scroll saw, you just release the little wing nut on the side, lift the finger guides, set the finger guides on the wood you're cutting, and then retighten the little screw on the side to hold that in place. If you don't use the finger guides, then they don't hold down your wood. You have more vibration. It causes the plate to chatter. It causes damage to the blade and could eventually cause an injury to you. So it's really important that you always make sure that your wood fits tightly underneath the finger guides, and they'll help hold it down. When you use the adjustments on the scroll saw, you should always make sure the speed, there's a little white line on the knob, make sure that little white line is pointing to roughly 2 o'clock. If you're thinking of a clock face, that's the correct speed. That's 1,200 strokes per minute, which is ideal for wood or for plastic. Once you've got everything set, you turn on the scroll saw, flip the switch, allow it to come up to speed, and then start your cutting. As you can see, scroll saw does really nice, intricate, clean shapes. And if you set it up correctly, you can cut a circle the size of the pupil of your eye using the scroll saw without ever making a relief cut. Okay, one of the biggest concerns we have with the bandsaws is there's different size bandsaws. This is the biggest bandsaw that's in the shop. Once you turn the bandsaw off, because it has such a big motor and so much momentum, it's going to spin for a really long time, even after the motor's stopped. If you don't stay with the machine until that blade stopped, or on machines that have brake pedals stop the machine, there's a real potential for people to get injured. So what we're going to demonstrate is this 2x4 is easily thicker than my wrist, even though it may not be quite as wide. It's easily thicker than my wrist would be. So if the bandsaw is running, and we'll let it run up to speed. If you're using the bandsaw and you finish and you turn the bandsaw off, the machine is off now. If you're walking across the shop, you're leaving the room, or someone else leaned into the bandsaw, even with the machine off, it cut a 2x4 in half very, very easily. That could be someone's finger, someone's wrist. So always make sure that the blade is stopped before you walk away from the machines. Anytime you do circles or curves on a bandsaw, because the way the bandsaw is designed, you should always make relief cuts to make the cutting process easier. A relief cut is simply a cut that comes into the curve that you're going to cut out. So if we start out with and do relief cuts first. The relief cuts are just a series of cuts that come down to the curve that you're going to cut out of your wood. Once you put those relief cuts in, when you start to cut that curve, each time you hit one of those relief cuts, that piece of wood will pop loose, and concept is it relieves the tension on the blade. That's why they call it a relief cut. So if we come back and cut the wood now, you can see that each piece just pops away as we go through the cut. It never puts any tension on the wide blades and prevents us from breaking blades, and it just makes the cutting process simpler. To stop, or you discover something's wrong, before you ever back out of a curve using a bandsaw, make sure that you stop the machine, stop the blade, make sure the blade's completely stopped, and then walk the piece of material back off of the blade. The reason is the way the bandsaw is designed, it spins one direction, continuous motion, one direction. It's got a guide in the back, come down, that as you cut in will keep the blade from moving any farther back than it should go, but coming forward there's nothing to prevent that blade from pulling back off of those guide wheels. So if you got deep into a cut and the blade's spinning and it binds, you can pull that blade forward and literally pull it right off of its track. So anytime you get into a curve, any type of curve, and you need to back out, even long straight lines, you should always stop the machine and stop the blade before you back out. Height adjustment for the bandsaw should never be more than a 1/2 inch of wood area between the material you're cutting and the roller bearing. On all bandsaws, there's just a little roller thumb guide on the back. It's just a thumb screw. You loosen that, lift up the entire guide piece, blade guide, make sure that you have no more than a 1/2 inch space, so that you have free motion, and you're ready to cut. That's all you have to do to set up the bandsaw. The large bandsaw has a brake pedal right here at the floor, so once you push the stop button, just press on that brake pedal, hold down until the blade stops, and as when the blade stops, you can release the pedal, reset the machine, and you can go back to whatever else you're doing. If the blade on the bandsaw breaks, it's usually because too much blade is exposed. If you have a lot of blade exposed and you're trying to cut real thin materials, the more the blade twists, the more likely you are to break the blade. If the blade does break, because it's a coiled blade, it's going to come down, it's going to hit the table and come back into itself, or it'll come down and hit the table and come to the right. So the right side of any bandsaw is no man's land. No one should be in this area, because if the blade were to break, it would come out and it would be just like a sword stabbing into a human body. So make sure that you never let anyone on the right side of the bandsaw while the machine's running. And very important, if you've got thin wood, make sure that you don't have any more blade exposed than you need to cut the wood. That will also prevent the blade from breaking and keeps you and the machine safer.